So hello friends, welcome back to our channel STM Mechatronics. So in this video we will see how to interface ST7735 LCD TFT display with STM microcontroller. Okay, so the microcontroller that we are going to use is blue pill controller board, right? STM32F103 C8 controller. So now this blue pill board is readily available and is most preferred. Along with this STM32F401 CCU6, that is a black pill board that is also easily available and readily used. Okay, now for this interface we are going to use a TFT display. Okay, if you go over here and see the device properties, right? So we have RGB, BGR, RGB. Okay, and we can select this, and this is part value ST7735R. If you go and click on the data sheet, you will be linked or you will be redirected to the data sheet part. Now for interface, first thing we will see is the connection diagrams, right? Okay, so PB0 is connected to res, that is reset. PB1 is connected to chip select. PB3 is connected as a SCL. PB4 is connected as data or command, and PB5 is connected as SDA. Okay, now for the LCD pins, right, these are connected, these 5 pins are connected to the microcontroller. Out of these pins, chip select, clock, data or command, and SDA, these pins are connected to as SPI pins. Okay, and reset pin is extra pin which can reset the display. Okay, now rest of the pins, that is D1 to D17, these are connected to VCC. The ID bar, that is this pin, read pin, it is connected to VCC. Why this pin is connected to VCC, that we will see in the data sheet. Okay, now P68, then IM2, IM1, IM0, SPI-4W, like we will see the connections for this pin from the data sheet. Okay, now coming to the data sheet. So ST7735 is a TFT controller driver. Okay, single chip TFT controller driver. Now it can provide up to 262 colors. Okay, now the TFT display that we have, right, it is of 132 into 168 into 18 bits. That this is the maximum resolution. So 132 rows, 162 columns, or reverse, like 162 rows, 132 columns, and 18 bit per pixel. Okay, now so the display resolution, as you can see over here, 132 columns, 162 rows, right, and in each pixel, that is in each cell, we have three colors, that is red, green, and blue, are G and B. Okay, now these are the settings for 132 into 162, right? We have to connect these hardware pins as 0 0 0, that is connect, we should connect these pins to ground. Now GM2, right, this pin, the GM2, out of these 3 bits, GM2 is connected to ground internally, so we have to connect these 2 pins to ground, that is 0 and 0. So if you see, we have connected GM1 and GM0 to ground. Okay, so that is first. Now we are going to use the 18 bit per pixel, that is 666, that is 384k bit frame. Okay, kilobit frame, and we are going to use a 4-line SPI interface. So coming over here, these are the colors. So now we will come to the pin descriptions and we will connect the pins accordingly in our Proteus simulation. Okay, now IM2, this is input pin for the driver. Okay, so this pin, if connected to 0, it is used as serial interface. If connected to VCC, it will be used as parallel interface. So for our application, we are going to use a serial interface. That's why we should connect this pin to 0, that is ground. So IM2, this pin is connected to ground. Okay, now IM1 and IM0, like these pins are used for parallel interface to select the like various versions of the parallel interface, 8-bit, 16-bit, 19-bit, 18-bit, right? But we are not going to use the parallel interface. That's why we are going to tie these pins to VCC or ground. So we have connected this IM1 and IM0 to ground. Now SPI 4W. So if connected to 0, like 3-line SPI is enabled. If connected to VCC, 4-line SPI is enabled. So we are connecting it to the VCC. That is, we want 4-line SPI interface. That's why we are connecting it to the VCC. Now reset pin. This is also input pin, but this pin should be connected to microcontroller. So reset pin is connected to microcontroller. CS, chip select, this is connected to microcontroller. Chip select, this is connected to microcontroller. Then DC, D or C, right? Data or command. So in serial interface, this pin is used as clock, SCL. So that's why it is connected to microcontroller, SCL. Now IDX, that is ID bar. It is used in parallel interface. It is not used in serial interface. So we have connected this pin to VCC. We will see why we connected this pin to VCC. Okay. Now RX bar. Okay. Write bar. So in 4-line SPI interface, this pin is used as data or command selection. That's why this pin is connected to MCU. Okay. So if you see, this pin is connected to MCU. Now in serial interface, D1 to 17 are not used and should be connected to VCC or ground. So from pin 1 to pin 17, it is connected to VCC. And D0 is used as data in out. Okay, so that's why it is connected to microcontroller unit. Data is connected to microcontroller unit. Okay, now TE, this is output pin. If not used, should be open. So TE, this is output pin from the driver. It is not used, should be open. Okay. Oscillator, OSC, if not used, please open this pin. Okay, so keep it as open. EXTC, this is during normal operation. Please open this pin. Okay, so during normal operation, open this pin. We are going to use a normal operation. Okay, so EXTC, we are going to keep this pin as open. Now GM2, so GM2 we have already seen, right? So we are going to use a 132 into 168 resolution, panel resolution. Okay, so that's why GM1 and GM0 is connected to ground. Now sRGBs, this is scanning. Okay, filter, basically RGB filter. So we have connected to ground. sRGB we have connected to ground. So we are going to use this R, G and B filter. That's why. Okay, now SMX, right? Scanning in X direction, scanning in Y direction, basically. So if set to ground is set to 0, the scanning will be from left to right. SMY, if set to 0, scanning will be from top to down, bottom. Okay, so SMX and SMY, these two pins are connected to ground. Now LCM, that is liquid crystal selection. Okay, normally white LC type, normally black LC type liquid crystal. So we are going to tie this as ground, LCM. Okay, we are going to tie this as ground. Now GS, gamma curve selection, we are going to tie this as ground. Okay, we will see in detail for this each pin, like what is the significance of each selecting each pin, either to connecting it, either like why we have connected it to VCC or ground. Okay, but for now we are only seeing the pin connections. Okay, the details are given in the next part also, so that we will see. Now TE select, so if TE select is connected to ground, it will be 162 lines. So TE select, it is connected to ground. So now we have covered all the pins, right? From T select, GS, LCM, SMX, SMY, okay, sRGB, EXTC, IM0 to IM2, SPI-4W, right? And P68 pin we have not connected, but it should be connected to ground. Now we will come to the timing diagram. So if you see this section number 8, right, it is given as timing charts. Now 8.1 is for the parallel interface, so we are not going to interface the parallel display in parallel interface. We are going to use the display in 4-line serial interface, so we can ignore this 3-line section, 3-line serial section. Now coming to the 4-line serial section, timing interface, right, timing diagrams. Now here you can see that the timing diagrams are given over here, right? So what should be the on time of the clock, right? What should be the high time, low time of the clock, the setup time of data, the hold time of data, right? The hold time of data or command, right? The data out hold times. What should be the high time for the clock, CS clock, right? So if you see this section, like 8.3, 4-line serial interface timings, right? We can observe that the minimum time, right, it is in nanoseconds, and among these nanoseconds, 60 nanosecond is the maximum, that is clock high and low periods. Okay, so what we can do is we can set up our controller such that the 60 nanoseconds will be the minimum time. Okay, now this is for 9.2 section is for functional descriptions. Okay, it is for parallel interface. Now coming to the serial interface. Okay, so IM2, it is connected to ground, and SPI-4W, it is connected to VCC. So the interface selected will be 4-line serial interface. Okay, now here you can see that the serial interface is either 3-line 9-bit, 4-line 8-bit bidirectional interface for communication between microcontroller and LCD driver. Okay, so we can see that for 4-line serial interface we are going to use chip select, data or command select, SCL, that is a clock, and SDA, that is data input output. Okay, now command write mode. The write mode of the interface means microcontroller write the command and data to the LCD, that is microcontroller, from microcontroller to LCD driver. Okay, in 4-line serial interface, data packet contains just transmission byte. Okay, control bit transferred over data or command selection pin. Now if data or command selection pin is low, it means the transmitted byte, it means as command byte. If data or command is high, it means transmission bytes will be stored into display data RAM. Okay. For serial interface, the most significant byte MSB is transmitted first. Okay. Now chip select is low, enable low. So a falling edge on chip select enables the serial interface and indicates the start of data transmission. Okay. So we will highlight this section. So here you can see that, right, this is 4-line serial interface format, transmission byte format. D7 will be transmitted first and D0 will be transmitted at last. For the next byte, D7 will be transmitted first, D7 will be transmitted at last. So these are two consecutive bytes are shown, right? You can see that when chip select is high, clock is ignored. Okay, so we can see that 4-line serial interface diagram. Okay, timing interface diagrams. So when chip select is low, the transmission is started, enabled. Okay, D7 is transmitted first, D0 is transmitted as last. D or C, right, DC bar, it is used for selecting between command and data. The byte, distinguish between the transmitted byte is whether command or data. So if DC pin is low, right, it is considered as command. If DC pin is high, it is considered as data. Okay, then we have to send the clocks. So in general, this is the timing diagram. So we will see in our Proteus simulation also. Here you can see that, like, 4-line serial interface. So this is for read device ID. Okay, we have not yet implemented this read device ID, but yes, we will be sending that. Now data transfer, break and recovery. Okay, so we have to take care. So if we are sending the first byte, then if the reset is low, right, then we have to wait for, and after the reset becomes high, we have to wait for more than 10 milliseconds to send the next data. Okay, else whatever the data bytes that have been transmitted, those will be ignored, straightforward ignored. Now when the chip select goes high, right, again we have to wait for more than 10 seconds. That is a precaution measurement. Now here you can see that data transfer pulse. When chip select is high, the clock is ignored. Now data transfer methods, like we are going to see this. We will see data color coding. This we will see. Okay. This is for parallel interface. The above section was for parallel interface. This one is for 3-line serial interface. Okay, now this section is for 4-line serial interface. So in this section it is shown that how we are going to send the data. So when we are going to pull the CS pin to low, right, data pin to high, it means we are going to send the data, right. D7 it will be sent first. Okay, D0 will be sent last. So D7 to D0, again D7 to D0, and again D7 to D0. It means we are sending the 3 bytes, that is total 18 bits of data. Okay, so this total 18 bits of data, right, this is 4-bit mode, 444, right? Sorry, this is 4-bit mode. So we are not going to use the 4-bit mode, we are going to use the 6-bit mode, right? So D7 to D0, D7 to D0, D7 to D0. So what we have to do is, whatever the 6 bits of depth for each LED, that is red, green or blue, right? So the 6 bits are transmitted first, then 2 ignored bits, that is either 0 or 1, then again 6 bits for green, again 2 ignored bits, again 6 bits for blue, and again 2 ignored bits. So in total 3 byte we are sending, that is in total 18 bits, we are only sending data for 1 pixel. Okay, we are only sending data for 1 pixel. Okay, so it is shown like this. Now configuring GM2 to GM0. See over here, reset is high, chip select is low, CL is low. Okay, so the datasheet contains more than 167 pages. So that's it for this video. We'll see, we'll continue in the next video with the datasheet, and we'll see how we can develop the drivers for the ST7735 SPI interface. Okay, that is 4-wire SPI interface. Now this is part 1. We will continue the series in part 2, part 3, and we will complete the whole code. Okay, to display the image, to display consecutive image, to display the animation, that is display the multiple image, right? So if you like the video, if you like my explanation, please hit like, share with your friends, and subscribe to our channel. We'll see you in the next video.